If you have a weather app on your phone, you might have noticed that the humidity is generally measured as a percentage. And you might be curious, what is this a percentage of? The answer is actually pretty straightforward. In meteorological forecasting, humidity is generally displayed as relative humidity, which the equation for it is the partial pressure of water divided by the vapor pressure of water. And the partial pressure of water is just the pressure of only the water vapor in a given volume of air, and the vapor pressure is if you have some liquid water and a vacuum, the liquid water will continuously evaporate and fill up the vacuum, and if it's a non-infinite amount of space and there's enough liquid water, eventually the vacuum will fill up and the pressure of the water vapor will be enough to stop any more liquid water from evaporating. And this is the equilibrium vapor pressure. And this increases as the temperature increases because the liquid water is more energetic, so it has an easier time evaporating. And since relative humidity is partial pressure divided by equilibrium vapor pressure, it's basically just a fancy way of saying the amount of water in the atmosphere relative to the amount of water that could be in the atmosphere. If you live in a place that has warm days, you're probably at least vaguely aware of the fact that humid days tend to feel much warmer than dry days. The main reason for this is that the closer that the partial pressure of water is to the equilibrium vapor pressure of water, the slower water evaporates. And this means that the sweat on your skin evaporates slower, and so it takes less heat away from your body. Another more minor reason is that water is more conductive to heat than normal air. And so if the temperature is high enough to actually be above your skin temperature, then if it's humid, the air will be able to conduct that heat to you faster, hence feels warmer. And there is a formula for how much warmer the air feels when it's humid. It's called the heat index, and while it's a fairly complicated model, it can be very accurately approximated by a relatively simple formula that is just the dry bulb temperature, basically the temperature of the air ignoring humidity and any radiation, so the pure temperature of the air, and the other factor is just relative humidity. The heat index can be approximated by this equation here. It gets a little bit inaccurate at about 90 degrees and above, but until then is pretty good. There is a link of this typed into a calculator in the description if you want to mess around with it. While most phone weather apps use the heat index to display the temperature, it is not the most accurate model. There is another factor, wind. And most news weather forecasting services use a different equation called the wind chill equation. The most commonly used version was developed by Australia in the 1980s and takes into account temperature and humidity, but also wind speed and the radiation from the sun.